Welcome to part two of this exploration. I hope you enjoyed your exploration so far and were able to discover how to take any quadratic equation, ax squared plus bx plus c equals 0, and convert it into an equivalent quadratic equation that can be solved using the square root method. That's going to look like some type of binomial being squared is equal to some constant number. Now, in this video, we're going to do a couple of things. First, we're going to test your discoveries to see if they really do work. We're then going to summarize and generalize this technique that we can use to convert any quadratic equation into something that can be used to be solved with the square root method. And finally, we're going to try a few more examples that look at a few nuances. All right, let's start by testing your discovery. To test, I have two quadratic equations here. That cannot be factored, and they also can't initially be solved using the square root method. So go ahead and use your discovery and your technique and see if you can solve them. Pause me, and then come back when you're ready. All right, welcome back. Here are the solutions. The first equation, using your discovery, hopefully you're able to convert it into this equation, x minus 3 squared is equal to 7, which is something you can solve using the square root method, and you'll get the two solutions, 3 plus the square root of 7 or 3 minus the square root of 7. For the second example, hopefully you're able to use your discovery to convert it into this quadratic, x plus 6 squared is equal to 38, which again, you can use the square root method. If you did not get these, you might want to pause, keep working on them. You might want to go back to the first video and watch some of the hints. Because what we're going to do next is we're going to just summarize and generalize this technique. What you've discovered is a technique called completing the square. And completing the square is a technique that can be used to solve any quadratic equation. So it's incredibly powerful. This technique is based on the idea that we can take any quadratic equation and convert it by completing the square into an equation that can be solved with the square root method. So I'm going to walk through our first test example just to emphasize some ideas and summarize this technique, and then we're going to go ahead and generalize it. Okay, so the idea with completing the square is that we want to focus only on the variable terms. So to do that, I'm going to subtract 2 from both sides to get my constant on the other side. So x squared minus 6x is equal to negative 2. Now I want to add a number here that will turn x squared minus 6x into a perfect square trinomial, into a trinomial that can be factored into a binomial squared. Hopefully through your exploration, you found some ways to do this. I'm just going to draw a quick area model just to emphasize a few things. If we have x squared here, to get a binomial squared, I'm going to have to take negative 6x and split it in half. So I know this is x minus 3, and the number 9 completes the square. We'll make this a perfect square trinomial. And with any equation, whatever you do to one side, you have to also do to the other. Awesome. I can now take this perfect square trinomial and factor it into x minus 3 squared, x minus 3 times x minus 3, and that's equal to 7. So at this point, we are so excited because now we've converted this quadratic into something that can be solved with the square root method. We know how to do this, taking the square root of both sides, plus or minus 7, and then adding 3 to both sides. All right, so hopefully that should feel very comfortable at this point. All right, mathematicians love to generalize. We can't help it. So let's generalize this technique using variables. And I'm going to start with a simple example. I'm going to start with a simple example where a is equal to 1. So we have x squared plus bx plus c equals 0. I want to focus only on my variable terms. So I'm going to isolate those by subtracting c from both sides. The next step is I want to complete the square, and I'm going to give us an area model again to visualize. We've got x squared here. I've got to take my middle term and split it in half. So b over 2x, b over 2x, which means the sides of my square are x plus b over 2. And finally, what's the value that's going to complete my square, that's going to make this a perfect square trinomial? Well, we've got to take b over 2 and square it, which is b squared over 4. So we can add that to both sides of the equation. And then write this perfect square trinomial. We can factor it into x plus b over 2 squared is equal to negative c plus b squared over 4. And then you can go from there. So take a minute. Did this make sense to you, this generalizing step? You may want to stop and kind of work that through for yourself and really make sure it makes sense before we go on to the end of this video where we're just going to work a couple of quick examples. Let's end with just a little bit of practice. I want you to pause me and solve both of these quadratic equations by completing the square. When you're done, come back and I'll show you the solutions and we'll talk a little bit more about number 2. Welcome back. Here's the solution to the first equation. X can either be negative 5 or 7. Either of those numbers will make the equation true. And I've added my work there. Okay, for the second one, here are the two solutions. Did you get it correct? If not, one thing I want to highlight, and if you got it correct, you're probably good to go and you're done with the video. What I want to highlight here is, did you notice that A does not equal 1? And in order to complete the square, we need A to be 1. So a great technique for this is divide both sides of your equation by A. So 4x squared plus 24x plus 28, divide that side by 4, and also divide the other side by 4. And once we distribute the division, we'll get x squared plus 6x plus 7 is equal to 0. And now this gives you something that you should solve from there. Now, don't be surprised. I gave you a really simple example here. Often when you divide by A, B and or C is not going to be a nice integer. It's going to be a fraction. No problem. Everything else works the same from there. Okay, so I hope you enjoyed this whole exploration and you have a good feeling now of how to solve any quadratic equation by completing the square. And I hope you enjoyed this exploration and discovery practice. If you have If you have any questions, come and talk to me. I'd love to hear your ideas. Talk to me or during our class or come to an office hours to discuss this. All right, bye-bye.